Hi, welcome to another 4AC e-learning video. In this video, we want to look at example 3.8c, which is found in your lecture notes. These questions have four parts. First part is calculate the total impedance ZT for the whole circuit. That means at this point, we look at this whole circuit. What's the total impedance? Part B, we want to calculate the currents I total, which is coming into this circuit, and the two branch currents I1 and I2. And we want to calculate the average power PT delivered to this circuit. And finally, we want to calculate the power factor of this circuit. Well, let's see how do we do this type of questions. Well, for part A, let us simplify the approach. We are asked to calculate the total impedance ZT, but ZT is comprises of a few impedance. First one, we can say this is Z L1. Let's call this. And this branch, we can call this Z1, and this whole branch, we can call this Z2. So we can see that from this circuit that Z1 and Z2 are in parallel. So let's list out everything first. Z1 is equals to the resistive component 1.5 ohm and minus J 1.2 because it's a capacitor. That's the rectangular form in ohms. Or in polar form, it's 1.92 angle minus 38.66 degrees ohms. Similarly, for Z2, I can write out the rectangular version. It's equals to 1 ohm plus J 0.2 minus J 0.8, which is equals to 1 minus J 0.6 ohms in rectangular form, or if I were to convert that to polar form, that would be 1.166 at the angle of minus 30.96 degrees ohms. Alright, so these are the two branch impedance. So first of all, I want to calculate is the two of them in parallel, Z1 and Z2 in parallel, to give me the so-called total impedance at the point. So writing out the formula will be Z1 multiplied by Z2 divided by Z1 plus Z2. Okay, this is a version of the impedance in parallel rules, so I can put them in. Now on the top, since it's a multiplication, I write them in polar form. 1.92 angle minus 38.66 degrees multiplied by 1.166 at an angle of minus 30.96 degrees. Okay. And then at the bottom, because they are to be added, so I use the rectangular version. Rectangular version is 1.5 minus J 1.2 plus 1 minus J 0.6. That will give me 2.238 angle minus 69.62 degrees divided by the denominator 1.5 plus 1, that will be 2.5 minus 1.2 and minus 0.6, minus j 1.8. That gives me 2.238 angle of minus 69.62 degrees over 3.08 at the angle of minus 35.75 degrees. That will give me, which is equals to 0.7266 angle minus 33.87 degrees. Now this is parallel, so it's ohms, right? Or if I want to write in the rectangular format, it would be 0.603 minus j 0.405 ohms. Therefore, the total impedance ZT is equals to ZL1 plus the combined impedance of Z1 and Z2. That, converting to rectangular, since I'm going to add them, I will have J 0.4 plus 0.603 minus J 0.405. That gives me 0.603 minus J 0.005. And that's approximately 0.6 at the angle of minus 0.475, so let's say 0.48 degrees ohms. So that's my answer for part A. Okay, for part B, we need to calculate the current I. And then later on we want to calculate I1 and I2, which are the branch current. Now using Ohm's law, I, total current, is just the voltage V, RE, divided by the total impedance that we have just calculated. That means 10 volts at an angle of 0 degrees divided by 0.6 at an angle of about 0.48 degrees. That gives me 16.67 ampere at an angle of 0.48 degrees. So that is the current, the phasor version of the current coming in to the circuit. Okay, now we want to calculate I1. Now to calculate I1, we make use of the current divider rule. So I1 is equals to the impedance of the other branch, which is Z2, over the total impedance, which is Z1 and Z2, multiplied by the incoming current I. So that gives me 1 plus J 0.2 minus J 0.8, which is Z2, divided by Z1 is 1.2 minus 1 minus J, sorry, plus 1.5, Maybe I should write in a better way. It's the standard way. Should be 1.5 minus J 1.2 plus 1 plus J 0.2 minus J 0.8. The whole thing multiplied by the current, which is 16.68, angle 0.48 degrees. So since I need to divide, I have to convert them to the polar version, which is 1.17, the angle of minus 30.96 degrees over 3.08 at the angle of minus 35.75 from our earlier calculation, multiplied by 16.67, angle 0.48 degrees. This one should be 7. That will give me an answer 6.33 at the angle of about the angle of 5.27 degrees ampere. And to calculate I2, I will have I2 is I minus I1, which is 16.67 at an angle of 0.48 degrees minus 6.33 at an angle of 5.27 degrees. Converting that to rectangular format, I will have 16.669 plus J 0. Okay, converting into rectangular form, I will have 16.669 plus J 0.1396 minus 6.303 plus J 0.581. That gives me 10.366 minus J 0.4414. That's in polar form is 10.375, angle minus 2.44 degrees ampere. Right, so in total I have the maximum current or the total current I1 and I2. So that's my answer for part B. So for the last part, part C, power factor FP is given as part C is not power factor. Part C is asking us to calculate what's the power dissipated. So power dissipated P is equals to E times I multiplied by cosine theta, which is the power factor, is equals to the voltage is 10 multiplied by 16.67 ampere with a cosine angle of 0.48 degrees. That gives me, that's 166.69 watts. And finally, the power factor Fp is equals to cosine of the phase angle between the voltage and current, which is 0.48 degrees, which is very close to 1.0. That means unity power factor. Alright, so that's my answer for this video. I hope you have learned something from watching this video. Thank you. Bye.